Hi everyone. In this video, we are going to do the rectangular coordinate system. There are different coordinate systems we use in mathematics, and this one is called rectangular coordinate system. Here are four learning objectives. Basically, we just learn very basics. First, if you're given a point, we want to be able to identify the two coordinates of that given point. One is for the horizontal value, one is for the vertical value. Then we want to be able to plot points in the coordinate system, coordinate plane. And a third one is that we want to be able to identify the location of a given point in terms of a quadrant. And finally, we are going to calculate the coordinates of the midpoint of the two given points. So let's get started. First, we want to introduce this rectangular coordinate system and how to find the coordinates of given point. First of all, if you look at this chart, it's our rectangular coordinate system. It is composed of two axes. One is horizontal one. An axis is nothing more than a number line. Okay, horizontal one and vertical one. That's why we call it a rectangular coordinate system, because if you have horizontal, you have vertical, like length and width. So this is our rectangular coordinate system. Some people also call it a Cartesian system. They're the same thing. So the zero is the origin, it's beginning point for both axes. Say the numbers go up from left to the right. The numbers also go up from bottom to the top in that direction. So now after this basics of the coordinate system, let's look at the first example. So now in this example, we want to determine the coordinates of each point shown in this system, in this chart. Let's do it in the alphabetical order. First is point A. Point A. Now to determine the horizontal coordinate for this point, which is in general, we use X and Y to label these two axes for the lack of specific meaning. In the real life, if you have specific meanings for these two axes, you need to label them with those specific meanings. So to find X coordinate, horizontal coordinate, you just draw this line in imagination so that it intercept with x-axis, then you read it. So this is true. We always write the horizontal coordinate first. That's why these two numbers are called ordered pairs. They have to be in that particular order all the time. Horizontal value first, then vertical value. To get a vertical coordinate, you draw a perpendicular line in imagination. Again, you don't have to draw it. And to the vertical axis, y-axis, look at the intersection point, which is the 3 in this case. So now, this is basically the location of this point in this plane. So 2 and 3. Now, after we get the first one done, the rest are very easy. B. So x is -2, y is 2. So -2 and 2, separated by comma. C and -3 and -1. Right? And D, where is D? D is here. Positive 2 for x and -2 for y. E, We'll see is on x-axis. Apparently, x itself is 4. Y, you draw a perpendicular line to y-axis is 0. So 4, 0. In other words, actually, any point on x-axis will automatically have a y coordinate being 0. Now the last point F is on the y-axis. So apparently x value is 0. You draw a perpendicular line to x-axis, that's 0. It makes sense actually. If your point is to the right, x will be positive, right? To the left, x will be negative. That's why it's on y-axis, it's always 0. Y value apparently is -5. So that's our first example. Now, second objective is that we want to plot or locate the point in the coordinate system. And we don't have to read this. It's very easy to do in this demonstration. If you read the textbook, certainly you need to read this, but you're watching a video. So example 2, plot and label the point described by each ordered pair of coordinates. So we are given ordered pair. So we have 3 of this. Let's do it one by one. First one is x is 4 and y is -2. All of these values are relative to the origin, which is the 0 point in the center here. So x is 4. From here, you go to x, that is 4. Don't draw a point yet, because a point is determined by 2 coordinates, not 1. So you go to the 4 for x value, then from here, you go to -2 for y value. Here's -2. Now, here is the point A. Yeah. So if you want to double check, you draw a perpendicular line to x-axis, you get x equal to 4. You draw a perpendicular line to y-axis, you get y equals -2, right? So let's look at B. -3, -3, -4, and that's here. Yeah, -3, -4, that's a B, label it as B. Now the third one, 0 and 5. 0 for x, you don't go to the right, you don't go to the left, y is 5, and that's here. So that's a C. Now I finish this problem. Okay, now another learning objective. Determine the quadrant for a given ordered pair. That means the location in terms of quadrants and for a given point. Now, first of all, what is a quadrant? So basically, we have this horizontal axis and vertical axis, and this whole surface is our coordinate system plane, extended to infinity in all directions on this surface. Now, these two number lines or 2 axes separate the whole plane into 4 quadrants, 4 parts. Each part is called a quadrant. And they are labeled with Roman numerals 1, 2, 3, 4 in this counterclocks direction. So this is the first one, quadrant number 1, quadrant number 2, number 3, number 4. What are these signs? Any point in quadrant 1, both coordinates are positive, because imagine in here, if you point in here, the x value is positive, so it's a right-hand side part of x. All of this x value will be positive because they're all corresponding to this part of x-axis. All of the left-hand side left to this y-axis, x value will be negative because they're all to the left of the 0 point for x values. In a similar manner, all of the y values above x-axis will be positive because that's where y value equals 0. Above them, they are positive. All the y values in this region and it's negative. That's why we have those all of the signs when we combine both x's together. Okay, now let's look at the next page. So we want to determine the quadrant for each ordered pair, for each point. So imagine x is negative, y is positive. X is negative means left-hand side. If we look at this again, x negative left-hand side, and y is positive, y is above. So in other words, this sign tells you the location, left upper corner. And that's the second quadrant. So the quadrant number 2. This is a right because the x is positive, and the lower corner. The right lower corner, that's fourth quadrant. And this one doesn't belong to, oh, these two are identical. I guess I made a mistake here. This is a 4, this is 2. Let's change it just for the sake of this example. Let's do 2 negative numbers, -2, -100. So this is left and the lower corner. This is quadrant number 3. And this one, x value 0, that means x is at the origin. Y value is positive. It goes like this. This is x, this is y. X is 0, y is positive. Suppose this is -1. So it's not in any of these 4 regions. It's on y-axis. So we say this doesn't belong to a quadrant. Quadrant. Yeah. Now next, find the midpoint of 2 points in the coordinate plane. So basically, let's look at this chart. This is a demonstration. We have this rectangular coordinate system. We have 2 points. And this is the first one, and the second one. This is the midpoint. How do we know it is midpoint? We cannot say look like it's in the middle. It look like it doesn't work in mathematics. We have to be precise. So if you look at this, the horizontal coordinates for these 2 points, the first one is 2. We only look at horizontal coordinates. The second one is 6. What's in the middle between 2 and 6 is 4, right? So exactly 2 units, 2 units. So this horizontal direction, this point is in the middle. How about in vertical direction? The vertical coordinate for the first point is 3. The vertical location coordinate of the second point is 9. What is in the middle between 3 and 9? That's 6. Each side is 3 units, right? So both x and y coordinates are in the middle. That's why this point is in the middle. So it's very easy to see it. Now let's look at this example. If we are given 2 points, how to find the coordinates of the midpoint. Now this is the formula. Actually, we don't really need a formula. Being middle means average of 2 points, 2 numbers. What's in the middle between 10 and 20 is 15. How do you get 15? 10 plus 20, which is the 30 divided by 2. That's 15. That's why in order for this point, we are given 2 points. Okay, this is a pair of numbers. This is another pair of numbers. We already demonstrated in the previous slides that in order for the point to be the midpoint, both x and y has to be, both x and y coordinates has to be in the middle, right? That's why we add x 2x coordinates and divide by 2 so that x coordinate is in the middle. We add y coordinates and divide by 2 so that y coordinate is also in the middle. As a result, this point is a midpoint. So now let's just do that. X midpoint. Okay. Let's use m to represent the middle equals 2 plus -4 divided by 2. X plus x divided by 2. That's a horizontal average. So this is -2 divided by 2, that's -1. Y midpoint, y coordinates, we look at y value, 6 and -14. Add them together, divided by 2. So 6 plus -14 is -8. Divided by 2, that's -4. So in the end, our midpoint is -1 and -4. So we solve it. Now, number B, this is the last one. There's no difference between this one and the previous one, just another practice problem. So middle point x coordinates equals, we don't have to use parentheses, -4 plus 9 divided by 2. So there's a 5 divided by 2, that's 2.5. Y midpoint coordinate 8 plus -1 divided by 2. Y value, Y value. The 7 divided by 2, 3.5. So our midpoint 2.5 and 3.5. And that's it. And that's all for this video.